developing next-generation research and technology, facilitating connections between AFRL industry and academia, unlocking innovation through a culture of collaboration. This is the AFRL Regional Network Midwest.
Hello everybody, I'm Antonio Ramirez. I'm a professor of welding, IT manufacturing metallurgy at the Welding Engineering Program at The Ohio State University. But I'm here today to tell you about this exciting project of welding in space that we are developing. Why we care about welding in space? We need to develop technologies so we can start building more larger structures in space or repair structures that are over there. As part of this, we are working with the Air Force and NASA to understand how the space conditions will affect welding processes.
Areas that we're specifically interested in are the extreme vacuum of space, very hot temperatures, very cold temperatures, and in future projects, the microgravity of space. We're particularly excited about the involvement of our students at the graduate level and undergraduate level in this project who will be completing the work, and the fact that they'll be the workforce for this new industry.
In my lab, we develop high-fidelity computational models for various joining processes which are always being invalidated or informed by experimental tests and advanced material characterization. In this project, we are constructing a temperature-dependent computational model to simulate laser welding process in the space condition. This model eventually will help us to find the optimum process parameters that can create structure with minimum defect and high integrity joint in the space conditions for high performance alloys such as titanium and aluminum that AFRL are interested in.
This is the vacuum chamber that we got from NASA Langley. It's currently rented to us for this project. They were originally manufactured for testing of electron beam welding in a vacuum.
We're going to be doing a number of testing in here on a couple different materials, and it's going to be in vacuum, and so we're going to be comparing the vacuum test to terrestrial tests like normal atmosphere to see differences in penetration, porosity, and different things like that.
A very critical part of this project is seeing how the welds behave when you're in different regimes of gravity, pressure, and temperature. This is something that's difficult to study, and a critical aspect of this is having visible cameras that are looking at these welds. So a couple of the things here that we have here are different varieties of weld and thermal cameras. We have two different weld cameras here, VC and the near IR/visible spectrum. And with these, we can look in very close into the weld pool and actually see how the weld pool is flowing and behaving during a weld, during all these different regimes, and they will both live inside the chamber. In addition to that, we have two thermal cameras. These thermal cameras will help us determine the actual thermal history of the weld and the different isothermals as you go away from the weld pool, and how that changes over these different regimes of gravity, temperature, and pressure. These are all critical aspects of taking this data into future simulations and just generally getting the standards and requirements up for actually using these processes in space.
So at this moment, what we've been working on is all of the hardware equipment, like the vacuum is functional, lasers fully integrated, Axios system is functioning. We have all the cameras and all the system. Now currently we're working on putting all of the equipment together so it can all run on one software together. We have already proceeded with all of the testing, and outside of that, the regulations we need for the parabolic flight, as well as the electrical box to power our entire system, is what is being worked on. So we have a working system. We're doing experiments with it. We're now working on making sure we have everything. We just press a button and everything functions and runs, and we can do the test in flight.
At this point, the chamber that you actually see here, the vacuum is fully operational. We have a laser put on it already. Laser is fully running. We are working right now on the software integration of the laser, but the laser is shining light. We are making welds already on different materials. We have been welding so far carbon steel and stainless steel. Very soon we'll move to the aluminum alloys and titanium alloys that Air Force is more interested on. By the way, we have some of that material already. However, the material that we have, the titanium, has certificates, the aluminum doesn't have, so we're procuring new aluminum that has full certificates. So this material has high pedigree, and the results will also have that as well. We also have progress on the power supply for the system. We are waiting for some corrections from NASA on the requirements that NASA has for these systems that are going to fly with them. Regarding the parabolic flight that we're going to be doing very soon, this parabolic flight has been rescheduled for July. This actually came good for us, give us some more time to finalize testing before we have to fly with it.
Yeah, this project's been underway for just a little under 6 months, and I'm pretty impressed with how quickly the team is moving. Granted, our AFRL Midwest Hub funding is just one piece of the larger puzzle supporting this project, but this team received a chamber from NASA about 1.5 years ago that required a decent number of upgrades to pull in modern technology to begin to test some of the hypotheses that we have.
I think this project revitalizes welding in general. And the fact that we're able to manufacture or even just assemble in space brings about, new awareness that can be taken further with future research.